My name is Makhan Gupta. My education and work experience has been in chemistry and biology. And as I work in this country in the electroplating process, I happen to learn, understand, and know more and more about the water being used, drinked in this country. And so I want to share my experience, what I know about water with this group. Thank you. I want to share with this group about the water. And now a question has been coming to me, and in a common word, people use, I like clean water. Someone say, I want a fresh water. Somebody says, I want water to be pure. Many times we talk about cold water, hot water, hard water, and soft water, what water to drink, what not to drink. So water has been coming up in our conversation day in, day out. So today, I want to share with our group what I know, what I understand the water is, or water is all about. Under no circumstances, please understand, this is a information only. I am not asking you guys to change your drinking habit, eating habits, or purchase one machine over the other. It's just information. Please enjoy the ride and try to understand more about water. I call Water 101, and IASC would like to call Wawa water. What may it may be, but let's talk more about it. Next, please. Here I am talking about some of the necessities of life, what we need on this earth. We must have water, we must have sunlight, we must have air, of course, food. And amazing it may sound, water, air, light, and most of the necessity of life, they are all free, and we do not have to pay for it. For example, all the population or all the civilization started around the rivers, and that's how the water and sunlight came into play. Next, please. So now, as I said, everything is free in nature, and there's plenty of it. Now, somebody asked me, okay, so that's the case, why do we pay for all these things? Reason being, as the civilization started near the water, we, as a socialized animal, decided to move away from the source of existence, either by choice or by the population growth or some other reasons. So what's happening is, as we move away, now we have to pay for these things, either for the delivery costs, for the convenience wherever we are, so we are far away from the natural resources, or we just don't like it as it is formed in the earth, nature, so we want to modify it. Sometimes we want to make it specially designed to fit my need. Other time, I may like one taste over the other. And our government always want to make sure that we have a water which is safe to drink. And to do that, our government or government all over the world have decided to have certain standard for the water comes to our homes. Next. These are the common sources. Where the water come from in nature? The most of the water on this earth is in the oceans, rivers, water under the ground, or we call so-called well water, rain, streams. Streams also fresh water coming from the rivers, or rainwater as it may collect in the ponds and lakes. So these are the major source of water. You may know more sources than I have listed. Thank you. Next. It's very important to talk about what's water. What are the properties of water? Water is colorless, odorless, tasteless. It does not have any color to it, any smell to it, or it doesn't taste one way or the other. And water is the most studied compound on this earth. The water is only one of the few, if not the only one, is the element which is available or found in nature as a solid, liquid, or gas. Next thing I want to talk about is let you know that water happens to be one of the biggest, greatest solvent in nature. What it means is most of the compound, most of the things, most of the stuff in this earth does dissolve in water, and solubility is high. Sometimes we don't even see it. So it's a great solvent. Next. The question came in my mind was, as we talk about someday we may run out of water on this earth, or drinking water on this earth. And question came in my mind was, is there more water above the earth or under the earth? And as I looked into the Google and other places, I found that amount of water under the earth is 3 times more than it is on the top of the earth. But the water on the earth is 400 kilometers below the earth's surface or the sea level. How do we get it? Very difficult. 2 companies, there was a German Continental, they were trying to go to the crust of the earth, trying to get this water. And with the best technology tools they have, they were able to drill a hole in the ground up to 9.1 kilometers. And after that, they were not able to go any lower than that because they did not have the tools, technology, know-how to go beyond that. And after that, there was another company called Kola, Peninsula of Russia. They decide to do the same experiment or same testing. And with the tool, technology, know-how, or by luck, they have been able to go a little longer, a little deeper into the crust. And they were able to go 12.2 kilometers. So as technology exists today, we cannot, or we have not been able to drill hole deep enough up to 400 kilometers to get the water from the earth's ground. So we have to live with what we have today in source of water. Next. This is a one thing that came to mind. Should I talk about it or should I not? And many times to understand a water or understand more about water, we have to know a little bit about the pH of water. What is a pH? pH, in 1909, there was a Danish chemist, Sorenen. He was trying to differentiate the acidity and alkalinity of fluid. And 1909, he came with a what we know today, pH. pH stands for potential hydrogen. pH is a symbol from the word potential hydrogen, and pH is a log value of hydrogen ion, and the pH value was artificially, or for the matter of understanding, was given a number 0 to 14, 7 in the middle. So number 1 or 0 be very acidic, or 14 being the highly alkaline, 7 is a neutral. And then to understand a little more about pH, if hydrogen ions are higher, then the value is lower and the liquid or subject is a low pH. If hydroxyl ions are higher, OH ions are higher, then it's alkaline. For example, if you go hydrochloric acid, HCl, only 1 hydrogen, no oxygen, no hydroxyl ion, so it's a very low pH. Sodium hydroxide, OH, it is alkalinity, it's alkaline. If there's a 1 H and 1 OH ion, that is become H2O or water, and the pH become in the middle, is neutralized, it's a 7. So this is how the pH works. And we'll talk a little more about it in a few coming slides. Next. Now, here, I want you to look at the picture on the right side. A lot of time we talk about the pH of certain liquids, certain things that we eat or that exist in our life, okay? And human body, pH is 735 to 745. This was a study done very recently in 2018. Human urine is 4.5 to 7.8. As you can see, a wide range. It is always, or most of the time, toward the acidic side. EPA, Environmental Protection Agency, they set a pH of drinking water 6.5 to 8.5. As somebody think that we must drink a pH water of 7, it is a myth, it's a misunderstanding. The pH regulation is 6.5 to 8.5. Just for the information, distilled water or RO, reverse osmosis water pH is 5 to 7, depending on the source, depending on the other process capabilities. The common bottled water that we drink today, the bottled water pH is 6.5 to 7.5, and the ocean water is about 8. It's on the alkaline side. And I wrote a word, rain or acid rain. Most of the time, as an atmosphere, it rains, it generally is on the acid side, and pH is 5 to 5.5. And let's look at the chart on the right side. As you see, I have listed the pH and the compound next to it. So for example, the Windex, the cleaner, is 11. And I look at the pH of blood, is about 7.5. Milk is about 6.5. And saliva is a 6 or a little lower. Black coffee is a 5. Tomato juice, black coffee is about same pH. Orange juice is lower. And soda that we drink is even lower than that. And vinegar and so on and so forth. So this chart helps us to understand that pH does affect our life, but we are always surrounded by a food, cleaning compound, detergents, or some other compound which are anywhere from pH 1 to 13, 14. So how that comes over life, it depends on us. Next. Now, next question comes in. As we talk about, we have hard water. Somebody said it's soft water. I don't like hard water. I'm going to buy something because water is too hard. So I want to talk about a few things. What is hard water, or what water is considered to be soft water? As we all know, all the mineral, or most of the mineral, because water happens to be the great solvent, all these minerals are soluble in water. And most of the common mineral, as the water goes on the surface, comes around the well, or flows to the river or mountain, it happens to dissolve all the compound the water comes in contact with. Could be chalk, could be gypsum, could be calcium, could be magnesium, carbonate, bicarbonate, sulfates, and different objects the water flows through or flows over. And for a purpose of understanding, anytime the conductivity of the water is less than between 100 to 100 parts per million, water considered to be soft. Water can be soft. If the conductivity or the TDS is higher than 200 parts per million, water is considered to be hard. And soft water, as we know, using the water softener in our homes, it is generally 10 to 15 parts per million. So this will help you to understand how hard water it is in our home, or how soft water is our home that we use the guideline. Next. Again, now you say, okay, so I don't want to test it. I don't know anything about it. So how do I know without testing it anything, I have a hard water? what are the signs of hard water at our home or the come in contact around us. The hard water leaves a film on your hand after washing. It feels a little like icky. Then, as you take the dishes out of dishwasher or hand washing, you will see spots, some white spots on it, some different spots on it, and they just don't look sparkly clean. Then the laundry may come out, little spots on them, little stains on them, and some residue that you may see. And eventually, if we keep on using hard water in our home, the water pressure goes down because the solids in the water deposit on the pipes in our home. And just like in narrowing arteries, the pipes become narrower and the water flows goes down. You can also see a lot of white, crusty, chalk-like material deposit on the shower, your faucet bases, or in the mirror, or on the glass on your tower, on your shower walls. And more often than other, as you take a shower, you may be using more soap or shampoo to create the suds or wash the hair or the clothing. So these are the signs of a hard water. Next. The flip side, opposite to that, what are the signs of soft water? Soft water, when you wash, bathe, it makes a lot of suds, and the clothes are come out a little cleaner, and it doesn't have mineral spots on them, and water pressure in your pipes stays the same because the pipes are always clean, and the hand, as you wash them, a little more cleaner, more slipperier, and you also see a less deposit around the faucets, base, or the shower doors. If you see some, you will find they are very soft, easy to remove. Next, please. Is hard water always bad or not so bad? So here are two ways I look at it. What are the health risks of hard water, or what are the benefit of hard water? This question came to me. I was in India one time, and one of my family member asked me, goes, "Uncle, in the US, you have the best water, you have the best food, plenty of it. Then why all the American take all the vitamins? Most of the vitamins sold in the world are sold in the USA." And at that time, I really either didn't want to answer it or don't have a good argument to reply that. So I kind of said, I don't know. Then I add the slide to this conversation today. What are the health risks and health benefit of water we drink or don't drink? Health risks are, if we drink hard water, it really don't create you any health issue whatsoever. If your hard water drinking doesn't hurt you at all, no health risk. It does give you a dry skin or itchy skin, and sometimes people, if they have eczema or skin disease, it may make it worse. Then it also changes the way skin pH is. If sometime our pH is higher, then it may lower it or higher it, and then it creates an issue on dry skin or other issues. And also, as we talk about it, hard water risk is eventually your pipes or the water conduit bringing water to your house may become clogged or narrowed. Now, what's the benefit? How does it help us? It does give us daily intake of minerals. If we need, somebody says, need a calcium, need a potassium, need a iron, need a magnesium, so on and so forth, hard water has some of these things, if not all of them, in there. So it does help you to maintain a somewhat a better level of vitamins in your body. And cardiovascularly, it's good for the heart. It's good for the heart. we talk a little about it, why soft water may not be good for heart. Again, I'm not a doctor. I'm just letting you know best I know. Next. As we talk about the clean water, we talk about the pure water, we talk about many type of water. Now, biggest reason we talk about it is we talk about water we drink. And drinking water, as we commonly know or we all know, is called potable water. Water is fit to drink. And potable water must be suitable for human consumption, that is for drinking, as well as for cooking and for human intake. Next. Then what is the fresh water? Somebody says, I like to drink fresh water. What is the fresh water? Fresh water is a water that naturally occur in nature, except seawater. Some reason seawater is not considered the natural occurring water or the fresh water, since it has a very, very high soluble compound of high alkalinity or salt compound. Second part is the fresh water is not always potable. The water may be fresh, but it may not be fit to drink. Most fresh water found this earth surface is not suitable for human consumption. That's a amazing that we take the water from the earth surface. We must do something to it to make it potable or fit to drink. Groundwater, that is the under the ground, is the largest active freshwater source. Most of the water available to us for the fresh water is the groundwater. Next. This is a very important slide. I want you to kind of drinking water standards. Right? So now we're talking about water we want to drink. So what water should we drink, or who controls it? What are the standards? All the animals on this earth must need water to drink and survive. However, there is not a one single standard for drinking water in this world. Internationally, there is not a single standard. Every country, or could be every county or state, as in USA, we may have a drinking water standard different than the other, and no international agency control the standard for drinking water. Next. Safe Drinking Water Act. In 1974, in the USA, EPA created a Safe Drinking Water Act, commonly known as SDWA. The standard was formed in 1974. It seemed like yesterday. Then it was revised in 1986 and again revised over by 1996. The reason they've been keep revising because our capability of testing are getting better. Our demands and needs for the purity of water is changing. So the SDWA also changing the standard. And the standards are set by EPA, Environmental Protection Agency, and they have set a standard for 90 water contamination standard in the water. So if you look at it, this study or the standard is a very, very high standard. 90 compound. Most of us cannot even look at it and find the 90 types of contamination the water could be. And our standard is set for 90 contamination standards. And EPA does a very good job controlling it. The exception is 13% of the population in USA do not use the water come under the act of EPA. This is well water, and well water is not controlled by EPA. Now, the one thing that I left out, that was bottled water. EPA, Environmental Protection Agency, does not control, check, inspect, certify the bottled water. Bottled water is controlled and managed agencies, FDA, Food and Drug Administration. So the bottled water come under the FDA. So Food Drug Administration is the one control the water in the bottles. And we talk a little more about FDA in coming slides. Next, please. Now, very few of us know about NSF. That is a National Sanitation Foundation. I have the privilege or chance to work with NSF a lot since I worked for a company, US Pipe and Foundry, who make the conduit or the pipe as small as 3-inch, as large as 72 inches or larger, for the water to flow in from the source of existence to our homes. And there's an agency called NSF, National Standard Foundation. And this company has a standard known as NSF 61. Basically, what happens is NSF says we want water as it leaves the source of delivery, could be a lake, could be a pond, could be whatever it may be, to our home. The quality of water should not, never will, it will not change the time it enters the conduit and comes to our home miles and miles and miles away. NSF has a lot of companies who make the product for the drinking water purpose. They consist of the manufacture of plumbing parts, they're plastic, they're metals, and many other companies. For example, sometime when you buy pots and pan, it has a stamp of NSF. Other time when you buy a shower head, it'll say NSF approved. What it means is the metal, the product, the seals, the rubbers, everything used in that particular pipe or a shower or a pot is controlled, inspected, certified by NSF, and it meets the NF standard 61. What it means is what you put in there, what comes out will be exactly the same. So I want you to kind of know a little bit more about NSF. Next time you go shopping, you buy pots and pans, shower head, or some other thing you use for food or water, look for a NSF seal. They're generally blue in color, as I have shown on my slides. Next, please. Again, let's come back to water. What are the different types of water, right? I mean, so I start listing. What are the types of water? Tap water, mineral water, spring water, purified water, distilled water, and sparkling water. Tap water, as it comes to our home through the tap, the faucet. Mineral water is generally naturally found in springs. As you may see, some beer and bottled water says come from such and such source of spring. And the purified water is when you take a bottled water, mineral water, any type of water, if you mechanically process, filter, or alter, that water becomes known as purified water. If you take water, boil it to a steam, condense the steam down, and change to water again, that is known as distilled water. And water with a full of carbon dioxide. If you take a water, you pass the carbon dioxide through it, it is known as carbonated water. As you may see, carbonated like Coke, Pepsi, Sprite, or a plain water we use in our home to make a soda stream. So that's known as carbonated water. Next, please. This is an interesting slide. I want you to see this picture in there. The tap water sold as bottled water. It's a heading. It's amazing. When you look at the bottled water, which is controlled by FDA, it will say the tap water is filtered, altered, changed, and sold as a bottled water. And I have listed some of the largest water companies, Alaska's, Ecofina, Dasani, so on and so forth. I could list more, but one thing I want you to see, the deceiving is, as you look at all the bottled water, they will have some kind of a blue color showing either as a bottle cap or the bottle level. They're trying to market the human mindset. There's something is a little blue or little greenish. This is the sign of purity, sign of being pure, sign of being good. So as you see, all the bottles, or most of the bottles you see in the marketplace, they will use some kind of a blue color to it, either writing, the label, the cover, or the bottom. And so they are trying to tell us, hey, my water is pure. Next, please. So next comes in, we talk about the filter. We all commonly say, well, I filter my water coming to my house. So here let's talk about what are the common filters are used or sold in our community or in our country or close to it. The most common filter we buy or use are called depth filters. These are cotton bound filter. The cotton rope is put on the plastic tubing over and over, certain depthness, and these are known as depth filter. And also they are activated charcoal filter. Other filters are made from a metal. They're known as metal alloy filter. These activated charcoal filter has a life, has to be replaced. Depth filter, life is very shorter, have to replace more often. Metallic alloy filter can be washed and reused, so the life is longer than most. The ceramic filter are somewhat same as a metallic alloy filters are, but they're commonly made from ceramic and they are easy breakable. And microfiltration or microfilters are the filters which are could be made from a fabric or the paper. And the HEPA filter is a very good example of microfilter. And of course, membrane filters are nothing more than a fabric the stuff filtered through. If you say a cheesecloth is probably the most common membrane filter there is. Next, please. So most of our homes, we soften the water. Why? So let's talk about a little more about water softening. Removing or replacing minerals from hard water is called water softening. So we're taking the minerals out and replace with some other minerals, and the water is called soft water. And this is a one method of softening. Other few methods are, we may use some kind of conditioning of the water, or we may use a different technology. There are few things listed: salt, non-salt base, precipitation method. That is just like if you remember in old days, we used to use alum or fatkari to the water. If you sprinkle the fatkari or the alum, which is also aluminum sulfate, over the water, it has tendency to coagulate the impurities and settle the bottom. And it is a very good example of then of course RO, reverse osmosis, and lime softening. That is lime is calcium bicarbonate. We do not use that for homes. It's a poisonous. And other thing is washing soda as mostly people in India, they knew when our our mother's grandmother, when they washed the clothes, they used to use a washing soda in the water to soften the water. So these are the some common water softening techniques. Some we use, some we do not. Next, please. Let's see. Mostly commonly used machine within the USA, best I know, is this particular water softening technique. In our homes, mostly in the garages, we will have a machine which we call water softener. Water comes in the machine, we put, and it goes through a brine or salt solution, sometimes filter, sometimes not filter, and water comes to house. And water comes in is known as a soft water. So here we are using a chemical, either sodium chloride or a potassium chloride, to charge the resin to get the water softer. Sodium and potassium are readily soluble in water compared to some other elements. So what we're doing is we are exchanging calcium or some other compound which create the hard water with a sodium ion, causing the water to be soft. The water softener has to recharge sometime as many as twice a week or more often, depending on the water consumption. And so it uses power, it needs a recharging. During recharging, it goes through a back wash, front wash, salt cycle, and a lot of water does goes to drain. And if you may not know it, the water coming out of it during the recharge cannot be used on a ground or the plant. It must go to the sewer. Since a lot of water is used to recharge, there's a great possibility, as the state of California, some other states, they are thinking about stopping the use of water softener for two reasons. Number one, it wastes a lot of water during recharge. Second is the water sewer system where the water goes to, where the water goes after we use the water, sewer system, they are having a very difficult time treating the high salt water coming to the facility. It does kill their bacteria, kill their bugs. So the cost of treating water at the sewer plants getting expensive and higher. And there's a great possibility that state of California, some other state may stop the use of this particular process. Next, please. The other people use a reverse osmosis. What's a reverse osmosis? The pressure is applied against a semi-permeable membrane. Osmotic pressure removes the water or ion molecule from the water, and pure water or the soft water comes through. The very seldom I see, or mostly people use a reverse osmosis in their home as a whole house RO system. Mostly people use RO under the sink at the kitchen, where the water is used for drinking and cooking only. So we are cleaning or altering the water to drink and cooking, but we are not changing the water coming to the whole house. And the membrane are very, very capable of stopping calcium, magnesium, don't go through. And RO also has to be continuously recharged, or the water goes to the sewer or go to the waste as we use the water. Some people, I don't know exact number, some people think that every glass of water that we take out of it to drink, about same amount of water goes to the drain as a it becomes harder not to come through the membrane. And so there's a lot of water wastage. And I don't remember, I believe RO is also hooked up to the power source. I have seen RO for industrial use, but most people are using RO for sink only. Next, please. Nobody use this process for drinking. When water is heated and vapors are cooled down, the water accumulates on the other end is known as distilled water. All the impurities, all the calcium, magnesium, iron, nitrates, nitrites, sulfates, sulfides, they stay in the bottom of the where the vapors come from, and we only get distilled water, process known as distillery. Distilled water comes to the other end. Distilled water is never used for drinking water at all. It's used for medicine values only. Nobody drinks the distilled water. It's very expensive to have. So I just brought the slide over to know what distillation is. Next, please. I have never seen this process in my life. This is a magnetic water treatment system, and no chemical use. Electronically, some or other minerals are pulled away from the water, and they are gone to the drain or somewhere, and the pure water come through. I have not seen this process. I have not used this process, and I do not know much about the process at all. Sorry about that. Next, please. This question always comes up. Is water, soft water, coming out the water softener, which is a salt or which is salt base, and salt could be sodium or a potassium. Most people use sodium. Sodium chloride, generally you buy a 40-pound bag for about $5, and calcium chloride generally bought at about $30 per 40 pound. So most people, because of cost and availability, use a sodium chloride. And some people may use a potassium. What's good, what's bad, it's up to you. But I want to tell you what's good and bad about the soft water. The good thing is, if your water coming to your home, a whole house water softener, you're using a less soap, less detergent wash waters. The fixture stays clean, pipe stays clean. It does not change any taste of the water coming through it. And your dishes are clean, your clothes are clean, and everything looks pretty good. Then you say, what's bad with it? What's wrong with it? The salt water coming through the pipe, if your pipes are made from a lead, the lead pipe, copper pipe or lead pipe, the water, soft water, will dissolve the lead or the copper, and it may become contaminated water with a high lead or a copper. And biggest part it does, it retains back the calcium, it sends back for drinking purpose on the other side, the sodium. And I looked at one of the information. You could have as much as 480 milligram per gallon or more sodium in your water you're drinking. And drinking the water with the sodium in this, not good for you. Okay, and so the people who have a heart issue, it is not good for them to drink a water high in sodium. And it is also very hard on the sewer system, as we talked earlier. Next, please. What's good and bad about the RO? Good thing, filters most contaminants, safe, environmentally friendly, is cheaper than bottled water, good, very good for cooking, and your pipe stays clean. if that's a whole house RO system. The bad part, water is wasted during regeneration. And if you have a whole house water RO, the pressure of water will go down because the membrane do not let all the water pressure come through. And you see on your kitchen faucet, it takes you longer to fill a glass with the RO water than take a glass full of just the water from the faucet. It's very expensive. You have to maintain the membranes. And World Health Organization, they had a warning out in 2020, 08, 09, 2020, came from a Google Internet. RO water causes more harm faster than drinking contaminated tap water. Very, very important to read. You rather, who's saying is RO water will cause you more harm than just drinking a faucet water, even it was contaminated. Now, I don't know all the study who has done, but this is the statement I have been able to shorten and put for the slide purpose. Thank you. Good. Next, please. Back to the bottled water. EPA does not or do not control the bottled water. Bottled water come under the jurisdiction of Food and Drug Administration. They control the specification for the bottled water. They also control how the water is processed in the bottling plant. They control the process. They also control the bottle, make sure they're clean, they're sanitized, and no bacteria ever found in the water. They also control there's no chemical contamination, and they will also sample the water and test the water from bottling plant as they need, or in case of complaint or a issue come up, and they have the authority to recall any water from any bottling company at any time they wish to do so in case there is a law which is not followed. Next, please. This is a, I wasn't sure, should I talk about this or don't talk about this? But I thought, let's do it. There are many ways let me think through again. If we are drinking water, what does make you sick? If we say I'm drinking water and I get sick of it, sick means have a stomach problem, have a diarrhea, have a vomiting, a different thing. These contamination or these issues are caused by the bacteria or bacterial growth in the water. Or some bacteria, they may be fit for one, not fit for the other. The best way to make sure there is no bacteria in the water and you are not at home, you're away from it, and you don't want to get sick about it, then what to do? The one thing that you may want to do is there's an ultraviolet light that kills the bacteria. You can, if you wanted to, you could have a ultraviolet light installed at the water source in your house. So basically, all the water coming in your house will be free from bacteria, and it will be good to drink. You will never get sick of it. Water could be hard, could be soft. That's beside the point. But one thing for sure, if water is exposed to the ultraviolet light, then bacteria are killed. Second thing is, you can use a handheld ultraviolet light, as you see in my hand. You can buy it for $35, $40, and this is a device run on a batteries, and basically you take this light and you hold it in your bottle, expose the ultraviolet light to the bottle for, as the instruction says on there, it'll kill all the bacteria and you can drink the water, won't get sick. So, for example, if you're going over a tour to the third world countries or some other country, you don't feel like drinking water there, you're not sure what water to drink, not to drink, take this one with you, buy a bottle of water or water anywhere you take, show the light, and water could be hard, could be soft. It will not give you diarrhea or won't make you sick. Won't make you sick. The other part is there is a other device. It's called a, I believe, called a biological straw or medical straw. Exactly, I forgot the word. And the picture I have is this blue picture here. This is a straw. It's a manual straw, no electric, no battery, nothing desired. It's more like a straw. It's the size of a thick pen. You can buy at Walmart or any store for about $10, $12. Sometimes you can buy a pack of 3 for 20. And basically, you put one end into the dirty water and suck in from the other end, and you'll get a clean water to drink. Most of the people go for camping. Most of the people go around the world. They don't know where they may not find a water. They will carry this in their backpack. And when they find a water puddle or water source, any water, and they can drink through the straw. And after a while, the straw get filled with the contaminants and water won't come through anymore. It's time to throw it away and get a new straw. So there are devices that you can use if you travel around the world or into the area where you may not find a water, that you can control the quality. So these are devices I thought good to list. Next, please. Now question come into mind. Okay, I talk about all kind of stuff. So now common man says, okay, Gupta, then what's good for me? Tap water or bottled water? Both water. I looked at a study done by Mayo Clinic, as you all know, very prestigious clinic in USA, is known as Mayo Clinic. This is a study they have done, and I just listed their main highlight points. Both type of water is comparable in terms of safety. Choice of tap or bottled water is a matter of personal preference. Taste varies person to person. Most people cannot tell the difference of taste. So basically, Mayo Clinic saying, for their study, both water are good to drink, both water are safe to drink. Mostly people cannot tell the difference of taste, and the both water are equally good to drink. Next, please. Now after all these things we talk about it, we live in Santa Clara County, and so question comes in, okay, so I live in Santa Clara County, and I live in a town, and my water comes from a tap faucet. So I don't want to do anything. Can I drink the water? Can I take a shower with the water? Can I do the dishes with the water? Can I do the laundry in the water? Am I safe? And where did the water come from? So I want to try to answer a couple of these things. First of all, Santa Clara County has a 3 ultra-modern, up-to-date water treatment plant where the water comes into our house. And these are Rinconda, Santa Clara Water Treatment Plant, and Pentencia Water Treatment Plant. So these are the 3 major facilities where water comes in our homes to drink. Next, please. And these 3 plants put together can produce on a demand up to 220 million gallon of good quality drinking water per day. And as the EPA says, our drinking water must be, no option, testing 90 contamination. All the 3 plants and other source of water supplier on a monthly basis, they are testing, reporting, publicly printing the result of their testing results on the internet, on the facility. Also, every 3 months, you will get a report in your water bill, a complete results of 90 contaminations in the water. So we're not only making a rule to control the 90 contaminants, we are also testing and giving the information to the common man, to the public, what 90 contamination are, what our results were as the water was sent out to the consumer. Plus, a question came up was the taste of water. These 3 treatment plants, they have a system in place that somebody tastes the water every 4 hours and results are recorded. So 90 contaminants plus the taste of the water has been tested, recorded, and available to the consumer on demand. So feel free to drink the tap water without a fear, because water we are drinking has been good potable water. Then a question comes in, okay, so 90 contaminants are fine. So how about the chlorination, or killing the bugs? In past years, the common method to kill the bugs were, you pass the chlorine gas through the water, you keep on passing it until there was enough chlorine coming out of water you could smell, taste, or see, then chlorination was stopped. And the chlorine dissipate or goes away with the sunlight. So this was the process. The process used today is called ozone treatment. So ozone is passed through the water to kill the bugs and remove the taste. Chlorination process has been changed. Now ammonia is used along with the chlorine to kill the bugs. And there's no chlorine taste or ammonia taste coming through the water at all. Plain chlorination is not done at these plants. The other thing I want to talk about is, as the state of California goes through either a long drought or a long, or I should say, short, heavy rainy season, the water get contamination or contaminated either by algae, a fungus, or just a growth in the surrounding area. And state of California, by tasting the water plus using the process, have been able to keep the musty smell away from it or a bad taste away from it. So this control we have on the drinking water by the county is, or by the, it's very, very good. So this will conclude my presentation for the day. I am available today and the future for any questioning. Please feel free to ask me question. I'll do my best to answer every question I possibly can. I do not have all the answers, but I'll do my best to answer best I know. Thank you very much. Thanks for attending. I appreciate you guys coming. Bye-bye.